All right, we're going to move on to question 19, and Jane wants to ask, in question 19, there's a parenthetical remark. Let each division on the x-axis be 1 unit, and let each division on the y-axis be 2 units. The reason is that if each division were 1 unit on both axes, there's not enough divisions here to do a graph in any meaningful sense.
So what are you saying? You're saying that
in the x-axis, this is 1, 2, 3, 4, 5. And on the y-axis is 2, 4, 6, 8, 10.
Oh, okay. Well, that would have been, yeah, it would have been
Just
nice to
different
do that
scales.
time.
Just different scales.
Well, that would have been nice on the scale of the graph, let x-axis be 1 unit. If you had said that, it would have been more, then let each division, it was like division, I didn't know what, it wasn't self-explanatory.
Okay.
For future.
Okay. So, let's put this away. So this is a graphing problem. Well, let me do, we're going to be graphing, so let's use this. Okay, so what I say is graph the equation y equals minus x squared
Go x and y.
from x greater than or equal to minus 4 to x less than or equal to 4. Okay, I can use this notation now, right, that x is in the range of minus 4 to 4. So how would I do that? Well,
We haven't had to study inequalities yet, so that doesn't pertain.
but you know it now, so I can use this language.
Oh, okay.
Okay. Okay.
And you can use any number, you don't have to use 4.
Well, you use any number you want.
Yeah.
Okay, well, let's make a table of x and y. Okay? And we'll go for minus 4, and we'll go in units, like this, of 1. Fine. There's minus 4 to 4. So the question is, what's the value of y? Well, y is minus x squared. Well, what is the square of minus 4? 16. And but I want the negative of that. So that would be minus 16. What about when x is equal to minus 3?
Why would you want negative? Oh, because why would you want y to be negative? Why would it be negative?
Okay. Okay, let's
Oh, because
evaluate.
negative 4 times negative 4. Okay.
Is
Isn't that
6
positive?
Yeah, but the equation is y equals minus x squared, not plus x squared, minus x squared.
But wouldn't minus 4 times minus 4 be 16?
Yes, and that would give you this part.
Yeah.
But there's a minus in front of the whole thing.
Oh, so minus, I see, minus 4. Okay.
Yes.
All right.
What about when x is equal to minus 3?
6.
What is the square of minus 3?
9.
9, and so that would be minus 9 because we have the minus coefficient. When x is equal to minus 2, what's the value of y?
Minus 4.
Mm-hmm. What about minus 1?
Minus 1.
Mm-hmm. What about 0?
0.
Okay, what about when x is equal to 1? When x is equal to 1, what is minus x squared? Minus 1,
Minus 1.
right? When x is equal to 2, what is minus 2 squared? Minus 4. When x is equal to 3,
Minus 9.
and when x is equal to 4. Okay, plotting time. Okay, so minus, let's see, 10, 12, 14, 16. Okay. Oh, and this is minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14, minus 16. Okay, here we go. X is equal to minus 4. 1, 2, 3, 4. Here we go. There's minus 4 and minus 16. Way down here. Right? That's my first data point. Minus 4, minus 16. Next one is minus 3 and minus 9. 1, 2, 3, and minus 9 would be right here. Agreed? Okay, what's next? Minus 2 and minus 4. Minus 2 and minus 4. Okay? 0 and 0, that's the origin. And now we're going to go out to the plus side. When x is equal to 1, y is equal to minus 1. Wait a minute. What happened to, I missed the point, didn't I? This is minus 2,
So-
minus 1, minus 1 is right there. Minus 1x is minus 1y. Okay, and so when x is equal to 1, y is equal to minus 1. When x is equal to 2, x is equal to minus 4. When x is equal to 3, minus 9. And when x is equal to 4, minus 16. Okay. You see those nice, beautiful dots there? Let's connect them.
Did anyone get that?
Yep. And so my question, or part B question is this equation linear? Is that a linear equation?
No.
Why not?
Not a straight line.
It's not a straight line. You know what it is?
It's a parabola.
It's a parabola, otherwise known as a parabola. Right. This is a parabola. And by the way, we're going to be getting into this big time after exam 2. After exam 2, we're going to get into quadratic equations and polynomials and parabolas and conic sections. Okay, so that's 19, and now we move on to 20. Okay, 20 is, true false can be the hardest of them all, because there's no calculations involved, you don't have to solve anything, you just have to know. So let's go through question, part A. A matrix is a rectangular array of numbers. That's true. The determinant of a matrix is another matrix. That's absolutely false. The determinant of a matrix is a number. Okay. C. When a matrix is in row echelon form, the leftmost column contains all zeros.
False.
That's so false. Okay. D. A linear system is consistent if it has only one solution.
I put true. Why isn't it true? Because it's linear.
Remember, a linear system is inconsistent if it has no solution. And it's consistent if it has either a unique solution or infinite number of solutions.
So it has a solution. You said that's wrong, it's false.
A linear system is consistent if it has only one solution. That's not a true statement.
So
The true statement is a linear system is consistent if it has one solution or infinite number of solutions.
Oh, so because it doesn't say or infinite?
Yeah,
Well, that's not really fair.
that's what makes this hard. I'm sorry, but
I
that's...
know, but I'm just saying that it is consistent if it has one solution, that's yes. And it's consistent if it has infinite solutions, that's a yes.
Jane, the converse is true. If there's a unique solution, then it's consistent. The converse of that statement is
Which
true,
is one
but the
solution.
statement itself is not
That was a
true.
trick question.
Well, it says only, so it's not really tricky.
Yeah, it says it has only one solution. That's not the definition of consistent. So,
Kind of trick question.
okay.
Seems like
But be
it's
looking for
making the
this.
question slower.
Yeah, you have to go through a little slow. E, when two lines intersect at right angles, the slope of one line is always the negative of the other. What do you think?
Two lines intersect at right angles.
When two lines are intersected at right angles, what do we call that property?
I thought they were, yeah, I thought that it was perpendicular.
Perpendicular.
It doesn't have to be a negative?
If two lines cross at right angles, they are perpendicular. So we're good with that, right?
And
What do you know about the slopes of two lines that are perpendicular?
one is negative than the other.
No.
Well, it equals
The
negative one.
product of the slopes is -1.
Yeah.
That doesn't mean that they're the negative of another. Suppose I had a slope, suppose one slope is equal to 2.
Another trick question.
What would the other slope be? If it were
It would be
perpendicular?
1/2.
It would be -1/2, right?
Yeah.
is minus 1/2 the negative of 2?
Well, it's a reciprocal.
But the question is,
Yeah.
The statement that we're trying to analyze is,
When two lines
When
intersect
two-
at right angles.
the slope of one line is always the negative.
of the other.
See, I thought it was the negative of the other, that's what I connected on, so it was.
These are not negatives of one another.
So
The
that-
only time that that statement would be true is if one slope would be 1 and the other slope would be minus 1. In that case, that's true. But you'll notice I say always.
And that's false. They're not always the negative of one another.
For example, think about this. Let's draw some slopes. Okay, I'm going to make this slope 1/2. Okay, that's what 1/2 looks like. Okay, that's m equals 1/2. Okay, let's look at the negative of that slope. That would be a slope of minus 1/2. That would look like this. And I think you will agree, that's not right angles. Does that doesn't look like 90 degrees.
No.
No, the slope is equal to minus 1/2. So it's not that they're negatives of one another. It's that it's the negative of the reciprocal. And let's just prove that, or show that. Let's take the negative reciprocal of 1/2. The negative reciprocal of 1/2 is minus 2. Well, what does that? That looks like, this is a negative 2 slope. I think you'll agree that's a right angle.
Okay, so maybe helpful on the practice exams to have some of these questions for this next set, that pertain to this next set, that are, have those little things in it that we have to look for, so that when we can't figure it out, we ask you ahead of time, say, that it says all, or always, or, then that would be helpful.
Okay.
Okay? I mean, I got most of them right, but I just, think for,
Okay, let's go to F. A matrix is said to be square if the number of rows equals the number of columns. That's true. The determinant of a matrix containing a row or column of all zeros is 0. We've seen that, right? G. Oh, no, that was G. H. If the determinant of the coefficient matrix of a linear system is 0, the system has no unique solution. So we're looking at the coefficient matrix of a linear system, we're calculating the determinant, and we're finding out it's 0. The question is, can that system have a unique solution or not?
I got it right, I put true, I can't remember.
That's right.
I can't remember.
That's right. Now why?
I can't remember.
Because you go back to Kramer's rule. Remember Kramer's rule? In Kramer's rule, the solution depended upon dividing by the determinant of the coefficient matrix. Remember we wrote down, when we just did this Kramer, we just did an example of Kramer's rule, where x is equal to the determinant of the big X matrix divided by the determinant of the coefficient matrix. Well, if the determinant of the coefficient matrix is 0, you can't have a solution. So that's where that comes from. If the determinant of the coefficient matrix is 0, there's no way you're going to get a solution, because you're going to try to divide by 0, and the only thing that will happen is your hair will catch on fire. That's what happens. That's why they tell you, don't divide by 0. It's very dangerous. Okay, and finally we come to the last of the true-false. If the determinant of a matrix is 0, then all the entries of the matrix are 0. What do you think of that?
Well, they should be, otherwise they have to be, right?
If the determinant of a matrix is 0, then all the entries of the matrix are 0.
Oh, no, doesn't mean it has to be, no.
No,
It used
that
to be
definitely
one-
not.
That used to be one of the, yeah.
The
one of the X, Y, or
converse,
Z, right,
the converse is true.
yeah.
The converse. If all the elements of a matrix are 0, you can be sure the determinant's 0. But it's not the other way around. I can show you.
The term, yeah, if it's just 0, then it's,
What if I had the matrix 3, 2, 6, 4? what is the determinant of that? There's not a single zero. But what's
It's 12 minus 12.
Right, 12 minus 12. So,
So that, maybe that's.
That's a false question. And finally, the bonus question.
we come to the bonus question. Oh,
Did anybody get the bonus
Yes.
question right?
Yeah, there were a number of people attempted it,
and several people got it, or came close to it. I was pretty generous on that, because it's a bonus question. So do you remember, I came in here with a circle?
You made it like a big,
Right, and
Yes.
it was cut up into 16 pieces. Not that that's important, but a whole bunch of slices. Remember, this is the pizza principle. And then what I did was, I took those pieces and I rearranged them. Like that. Like that. All the way down to the very last piece. Okay? Remember that? And we got kind of a rectangle out of it. And so, you know, the area of a rectangle is its length times its width. Right? Well, what's the width of this rectangle? Oh, if this slice looks like let's say it came from that slice right there. Okay? So this distance is just the radius. Right? And this distance, if you look carefully, it's all formed from the outer part of the circle. And so half of the outer part of the circle is on this side of my rectangle, and the other half of the circle, of the outer part of the circle, the circumference of the circle, is on the other side. So this length is the circumference divided by 2. So if you look, these are all the curvy parts, right? So those are all the curvy parts. Okay, so the area is the length, which is c over 2 times the width, which is the radius.
It's C over what?
C over 2.
How do you know it's C over 2?
Okay. The side of the rectangle is composed of the curved part of the circle. You see all these slices? Okay, that part of the slice.
Did you go over that?
Yeah, it was right there. I mean, I
I
did it right there.
remember the pi thing, but I don't remember the C2. But anyway, go ahead.
But you can see that every piece of this.
Radius C2, okay, you did go through that, yeah.
Yeah. Okay, but what is the circumference of a circle in terms of the radius? Circumference is 2 pi r, right? The circumference is 2 pi times the radius. The circumference is 2 pi times the radius. It's pi times the diameter, right? The circumference of a circle is pi times the diameter. So the circumference is equal to 2 pi r. The 2's cancel, and I get pi r times r is r squared. Pi r squared.
So that's the answer? Pi r squared?
Yeah, that's how what I'm saying is, oh, no, that's not, no, that's what I did in class. What I was asking for here was, what's the aspect ratio of this rectangle? The aspect ratio of a rectangle, the aspect ratio, I don't know what you want to call it, alpha, say, is the width, or the length, divided by the length divided by the, the length divided by the width. I'm getting ahead of myself. You know on your television or your computer monitor, there's an aspect ratio? Like from computer monitors, the old monitors were a ratio of 4 to 3. They would write it down like that. That means it's 4 times longer than it is, it's 4 units long and 3 units high. That's called the aspect ratio of a rectangle. What's the aspect ratio of a square? 1. Right? The aspect ratio of a square is 1. The aspect ratio of an old-time computer monitor is 4 to 3. I don't know what the new ones are. Anyway, so this has an aspect ratio. It's the length divided by the width. Well, what's the length? Well, the length is the circumference divided by 2, and the width is the radius. But the circumference divided by 2, what's the circumference? It's 2 pi r divided by 2 over r, which is pi r over r, which is pi. The aspect ratio of this rectangle is pi. It's pi times longer than it is wide.
Okay, so.
That's all it says.
So you're saying the area is pi?
No, the area is pi r squared.
It says here, what is the aspect ratio of this rectangle? The ratio of its length to its width. So, so the breakdown, what's that little funny thing you got there?
That's alpha.
Alpha, what does that mean?
Okay, aspect ratio A.
Oh, you mean A, so then A equals, it
It has
just,
to be anything.
Yeah, I mean, whatever symbol you want to make for aspect ratio.
but it's not the area.
No. That's why I kind of moved over to the Greek. Let it be alpha, but the aspect ratio is the length divided by the width.
Okay, well, I'm just trying to figure out what the formula is here, and it's a little confusing the way you have it written down there.
Right, I say, what is the
So you've
ratio
got
of the
the,
length to its
okay,
width?
so you've got the aspect equals the length over the width, which equals your C2 over the ratio.
Right, we said that half of the circumference accounts for the length of this rectangle, and its width, we said, was the radius of
So the C2 is the 2 pi r.
2 pi r is in fact the circumference. 2 pi times the radius is the circumference of the circle.
Which it's not the C, it's not 2 pi, it's
Yeah.
not 2 pi CR.
Circumference of a circle is 2 pi times its radius.
You lost me.
Okay.
Forget about it.
Okay, it's a bonus question.
Well, regardless,
Okay.
you know.
How about the others? So-so?
I kind of got it.
You kind of, okay. Cassandra, what do you think?
Oh, I'm totally lost.
Totally. Hey, Kyle? Is any of this kind of okay with you?
Yeah, it's not terribly difficult.
Okay. I'm just not explaining it well perhaps, but
I just wrote 3.1415 instead of 5.
good enough for me. Is that what you wrote down?
Yeah.
And did you get credit for it?
No.
You should have gotten some points. You should have gotten some points. Well, come see me.
That's all right.
And that's it. So again, I want to emphasize that the next midterm will have fewer problems and you'll have more time.
Okay.
You'll have all 2 hours and 20 minutes and there will be fewer problems so that you will have the opportunity not only to finish, but to check some of your answers.
Can you recheck the total on my thing?
Yeah.
I came up with 2 more points, I get 2 more points.
Yes.
So, I mean, give it to you.
That would make me very happy.
And then.
That would
you
make
can
me
check-
very happy.
Well, I mean, I just,
Because I have a feeling that in that quadrant analysis I did, the quadrant analysis of when we plotted grades versus
Yeah.
amount of homework done, there was one point in the fourth quadrant. Usually the fourth quadrant is empty. There was one point in the fourth.
That was me, probably.
Was just under that line. It was just in the fourth quadrant by a hair. And if we give you 2 points, that'll put you into the first quadrant. And that's the kind of thing, then that means nobody was in that fourth quadrant, which is exactly the way it should be.
all right, well, okay, I just think, should I give this to you, or you
Well-
gonna take a look at it later, or what?
Yeah, let me take a look at it. I will take a look.
Look at my homework.
Yeah, you can turn all
Well,
that
you
in.
already checked one of them, you didn't check the other 4 or 5 sections that I highlighted.
Okay.
So I need for you to, that was part of the thing
So
for you to do.
say goodnight to the people listening on the internet.
Oh,
Good night.
good night.
Good night.
You forgot that they were.